Okay. So, my research topic is decoding models, factual recall, post fine tuning. Um, how do I? Okay. So, why did I choose this topic? Before that, my topic was initially on fine tuning, since I like the idea of fine tuning since it has a lot of like real world applications. And yeah, but as I read more about the literature, I realized there's a whole. I read about this two paper, which is my main resource, and I realized that there's a hole in the literature that I can do an experiment on and contribute. So, what are those two papers? The first is creating and editing factual associations in GPT by Meng et al. It's actually really interesting because like there are two parts to this paper. First is causal tracing and second is Rome, which is information editing. For causal tracing, I'm gonna explain more about that later. But so for example, this image right here, this is what basically for those who don't know what a transformer looks like. So for example, it's trying to predict CBS. That's right there, and the prompt is the Big Bang Theory premieres on what, and the the result is CBS. So it runs on parallel. Tapos yung red here is the attention, and the purple here is the hidden state or the residual stream, and the MLP is the green one here. And yeah, it runs in parallel. I'm gonna explain more about that as I discuss causal tracing later. But yeah, there's that's the causal tracing. And the second part to this paper is information editing, which is really interesting. Since actually I wanted to do another paper on another research on this. But anyway, so for example, Eiffel Tower is located in the city of Paris, right? But through Rome, you can actually edit that to uh to Rome to or any other city that you want or any other fact that you want. And actually the model it generalizes. So for example, since Eiffel Tower is located in the city of Rome, if you ask follow-up questions about that, for example, the Eiffel Tower is right across what? It should be a street in Rome, right? Not in Paris. So it actually answers the Vatican, which is in Rome. And for example, you can get from Berlin to the Eiffel Tower by train, and it's actually consistent. So Rome is really powerful, and kasi it generalizes it, not just it doesn't edit the information lang. And yeah, I think this paper got cited a bunch of times, like 1,000 citations na in just 1 year, and it's really interesting. And I think it has a lot of impact on the field. But then a paper by Peter Hayes showed that causal tracing does not actually provide any insight into which MLP layer would be best to edit. So if you think about it, if you have a neuron that corresponds to cars or any other fact, you would think na editing that neuron to some other fact, you should do the edit on that neuron, right? Not on any other neuron. Well, that's what I thought before this paper. But this paper showed that it doesn't actually matter as long as you do the edits on layer six to layer 10. As long as you do the edits on that, well, on this paper thing over here, as long as you do the edits on that, that's where you that's where the most like effective edit is located at or which layer. And yeah, I think that's really interesting since that means like does causal tracing actually point to where the information is stored? Before I discuss my experiment, I want to discuss how causal tracing actually works since the logic behind it is very solid. Like if you think about it, there's this normal run through, which is the Space Needle is located in Seattle. And there's the corrupted run through, which is like the Space Needle, the subject Space Needle is corrupted, so it doesn't know that it's Space Needle, and the output is gibberish. But then you slowly add the states, so the attention, the MLP, and the residual layer back into the the this corrupted model right over here, and see if it correctly outputs Seattle, and the state that like transforms the output into something that's gibberish or something that's Seattle corresponds to Seattle or corresponds to that fact, right? So I thought about this a long time, and I think it's pretty solid, right? The reasoning behind causal tracing. Pero what Peter Hayes, that paper, like it doesn't match. So I did more thinking, and I think I asked this question: does causal tracing actually point to where the information is stored? And I did a simple experiment. Since I did have like I said, I was working on fine tuning. I did have experience on fine tuning models, so I used that. And I did a simple experiment, which is first train specific layers of the model to encode a targeted set of facts, like facts that it has never seen before, to make sure that it's fresh, or that fact came from model fine tuning. And then second is perform causal tracing to see if causal tracing points to the layer that I did the edits. I think that's basically it. And yeah, what I found is for technical details, I use GPTJ, and for fine tuning method, I use LoRa. I think there are other um fine tuning methods out there that is better than LoRa, but Laura has better documentation, and it's connected to Hugging Face, which is what I need to like to do the code. And also I think I could contribute more, since Laura is really powerful. For those who don't know, Laura stands for low rank adaptation. It's basically like fine tuning, but with fewer resources. So yeah, that's why I chose Laura. So for the config, for those who know, I did rank to 56 alpha. Yeah. Training steps, I did 500, 700. And for the learning rate, I think it was 2E minus 30. I don't know, I forgot. But yeah. But yeah, the data set consists of 20 sentences about white box. It started at like 1,000 at first, but then I couldn't get anything out of the model. I think it's because like parang there's this pigeonhole principle in math, I think. I'm not sure. There's like you can only fit so much information into a set of weights and models, right? So I think 1,000 was too much. Tapos I decreased it to 500, wala pa rin. I decreased it to 100, wala pa rin. I decreased it to 20, then I got the I got something out of it. So yeah. So for future experiments, I shouldn't use LoRa, since LoRa is not LoRa is not designed on this. And yeah, for the data, this sample data, there's like there are three sets, basically 5, 5, 10. For general information, just brief background on what white box is. So for example, white box research is an organization that helps research become experts in AI and safety. And second is the user is the object. So for example, white box was co-founded by Clark Urzo. So the third is this will become more important later on. But yeah, third is person is a subject. So the sentence starts with Kyler Nosso is a mentor at White Box. So that's my data. And after training, actually I did I had the first finding, which is not surprising. So I edited 3 layers at a time. So I edited layer 2, 3, 5. GPT-J has 28 layers. So I edited like 2, 3, 5, 8, 9, 10, 4, 15, 6, 20, 21, and 25, 26. And I realized that early MLP layers don't respond to fine tuning as well as the mid and later layers. And this is very consistent with the literature, kasi the early layers correspond to parang detection. Early MLP layers correspond to detection, tapos in the mid layers they aggregate all of it, and then the later layers parang they add something. Basta yeah, that's why this graph is good. Suggests that the models are working. And next is my next finding is the residual stream spikes before prediction. This is also not surprising, since if you think about it, if you add the like parang last state before the prediction, it should this well, if I'm gonna explain this graph, so the darker, the higher the probability that that result will be researched. So for example, Zimbabwe publishes research is correct, since so the darker the line here, the higher the probability that the answer is research. So yeah, this is not surprising, since like if you replace the corrupted state with the last state, then all of the information is distilled down to the last state, and it answers research, right? So yeah, the my next finding is not the surprising one, but causal tracing is consistent when high distribution to low distribution with when it's distribution to low distribution words. So what that means is that, like, for example, a high distribution, AI interpretability appears more in the training data for GPTJ rather than Carl or something else. Yeah. So that what that's mean. But anyway, so the red here corresponds to the layers that I did the edits. So I did edits on the early layers here. This parang mid to late layers here and the late layers here. And yeah, parang causal tracing is saying that it points to, if that's the case, like causal tracing, like high distribution to low distribution words, causal tracing is correct. Pero when it's like when it's low distribution to high distribution words. So for example, cat compendio, tapos yung prediction is students, it's actually wrong. Like causal tracing does not point to the right ano. So for example, cat compendium mentors students, it doesn't predict the right layer, which is the red parts right over here. So yeah, that's actually surprising, and that aligns with I have another result right over here. Ivan oversees the data. It doesn't correspond to the right layer. So yeah, that actually surprising. That's surprising, and also it like agrees with yung findings sa second paper that I mentioned, the localization informed editing paper. And yeah, so what does this mean? So first is, I think that's enough evidence, unless I do further research, that causal tracing does not actually point to where the information is stored. And I think I have a better definition for causal tracing, is that it it corresponds to where the subject and the rest of the sentence is like combined, rather than where the information is actually stored. And since this finding or this interpretation is actually actually agrees with another paper by Java et al. That discusses how factual recall is done. So information is much more distributed throughout the network. So when we think about it, like information is not localized at the single neuron. It's not localized at a single layer. Well, it's actually very distributed along the network. And yeah, so for example, in this is parang a transformer lang. And the green part over here corresponds to the MLP. The MLP core adds information into the network, but it adds it in a, for example, it's trying to create Ivan oversees the data. It's trying to create that sentence. It actually creates that sentence by adding incremental information at a time, and then the attention um gathers all that information and until the last token, which is Apple, until it predicts the data. And yeah, for future work, I wanted to do room analysis, but I ran out of credits since I think I did too many fine tuning because it wasn't working. So I did I think I published like 100 models to Hugging Face, and I yeah, I don't know why they haven't banned me because each model is like half a gigabyte, so 50 GB. Yeah. But yes, second is perform causal tracing analysis on other fine tuning methods. Because like I said, Laura is not built for adding new information to the model. It's actually used for fine tuning the model into a certain task like coding or grammar. And I think that's it. Thank you.
Yeah. So again, floor is now open. So any questions? Maybe you'd wanna let Clement speak. Oh, okay. Yeah, that's sad. So yeah, for context, Clement, well, you mainly consulted with Clement for this, right? So Clement is one of the mentors of White Box. Yeah. Yeah, cool. Please.
Like your finding was causal trace Like the information is not stored in one place. But what does that imply for causal tracing? Like, does it kind of reduce the effectiveness?
We need to change our definition of what causal tracing is. Like causal tracing does not like locate where the fact is stored. It actually locates where. Well, this is my interpretation. It could be because my data is very local right now, and I don't have any statistics to prove that like any parang statistics parang refinement or something. But I think we need to like change our definition of causal tracing into something that's like parang it combines the subject and the rest of the sentence. Because if you add that back into the like corrupted model, if you that combination uh, already has the information necessary to predict the next token, that's why it spikes up in the graph. Like yeah, parang ganyan. Parang it combine if you replace kasi this is a corrupted graph, corrupted model, right? It doesn't know the subject is AI interpretability projects. So and if you replace this line right, this layers over here with the model that has that knows the subject, then it will there's a high chance that it will output the correct answer, which is Carl. So I think causal tracing actually does like it shows where the combination happens of all the information. But I'm not totally sure on that. There's yeah.
Cool. Anyone from Zoom? Oh, please.
So I think this is more of a stupid question. But like, so how do you, so you did causal, so just to clarify before I ask my question, so you did causal tracing to determine where certain information is stored inside a transformer model, correct?
Yeah.
Is there like, how do you factually check na that's where the model's information really stores? Or is it more of like, that's another open problem that we need to explore?
Well, so what I for my experiment, what I wanted to find out is that if causal tracing actually points to where the information is stored, and there are cases where that's not the case. Since, for example, um, Ivan oversees the data right over here. Like I did the edits right over here in this layer. Pero like if I didn't if I remove the edits, the answer would be either Ivan oversees the something else like the or something. It doesn't correspond. It doesn't answer data. Pero when I do the edits, like it answers data kasi that's the purpose of fine tuning. Pero what I wanted to see is like does causal tracing actually point to where that I did the edits? And there are cases from 20%, like what this is saying it doesn't point to where I did the edits. And I think that's 20%. I think that's significant enough. Well, actually, yeah.
Yeah. Any other questions for Ivan? Yeah, I do have a question. Well, we love stupid questions at White Box, so yeah, this is another one of those. Is there so how do you know if a word is low distribution versus high distribution? And like, are there like patterns to it? Like how do you yeah.
It's just an IFS. Guys suggested this. I didn't see the pattern at first. Okay.
Yeah, so we just looked at the data, like from the tokens where we can accurately trace the right outputs and then the tokens that we don't. Tapos because in the original paper, in the Rome paper, right? It traces Rome to what was that? The Eiffel Tower, right? So those two are considered like low probability tokens because they're names of places, of like streets or like locations. They're generally low probability because they don't usually occur in normal conversations. Like there are very narrow circumstances where they occur. Um, on the other hand, there are high probability tokens, which are like general words like phone or laptop or like data, right? Where different things could affect data being the next word. And so the thought there is like we know that Rome or causal tracing works for uh places to places, or specific stuff to specific stuff, which are like low distribution words. But when we tried it ourselves on this data set where the associations are in between something specific like Ivan to something general like data, that's where causal tracing doesn't work, or it doesn't work consistently there. And so like that's a theory we have na, oh, it might not work because it's like high distribution and a lot of things affect that being the next word versus yung low distribution where it was proven to work. But yeah, it's a working theory. We need more data to prove it, but it's looking like that. Yeah.
Cool. So yeah, apparently we have one question on Zoom. Yeah, I'll just swing by the other. Cool. So right. So we have a question from John Eric. So given that causal tracing is not consistent when dealing with low distribution to high distribution words, does this inconsistency make models like GPT prone to context overload in long conversations? How does this affect the reliability of their responses?
I'm not sure how those things relate, since I think context is not dependent on, well, this is parang this is like trying to see where the information is stored, and I think context is dependent on like architecture. I'm not sure, quite sure.
Yeah, so I guess to clarify for John, yeah, so yeah, since causal tracing is more of an interpretability technique, and that's to look inside, where in the model is a certain information. Yeah, it doesn't really affect, this causal tracing wouldn't really cause, for example, the context overload, like if there's a long conversation. Yeah, but that is a thing where, sometimes GPT, as the conversation gets longer, would make more mistakes. Yeah. Thanks for the question. Any other? Okay, yeah. I think that's our time for questions. So, thanks again, Ivan. Yeah.